All right, hi guys, and welcome. This is our hodgepodge chapter. We're going to have two sections from chapter 5, two sections from chapter 8, two sections from chapter 11, and then we'll have a test over all of them. Chapter 5, we're going to look at exponents and exponent rules. If you entered this into your calculator, 4 squared, you're going to come up with the answer 16, okay? Because that's like 4 times 4. On this next one, if you enter this just like it is with the parentheses into your calculator, you will also come up with 16, because that is -4 times -4. All right? But this third one, you do come up with -16, because what that third one is saying is, I'm going to square 4, so I'm going to have 4 times 4, plus I have the negative out front, giving me that -16. So please note, when you are entering things into the calculator, if you are squaring this negative number here, please make sure you put parentheses around it or know that the answer should be positive, okay? So always try to put parentheses. There will be a lot of calculator operator error. With that in mind, can you find me 3x squared y when x is equal to -3 and y is equal to 4? So you come in, you replace x with -3, you're going to square it times 4. All right, so then I have 3 times -3 squared, so that's negative times a negative makes a +9 times 4. And that is equal to, I don't know, 27 times 4? Which is 108. All right, on to the next. You're going to come across this. This is like saying x times x, so that's what x squared is, times x times x times x. How many x's do I have? Well, I have 5 of them, so that would be x to the 5th. Now, look to see if there's another way we could have done that without having to write out 5 x's. Thankfully, because at some point we're going to get big problems. We're going to get big exponents, and you're just not going to write out 20 x's. Okay? And if you can see that 2 and the 3, how they relate to 5, you can get 2 and 3 by adding them together. So if you have the same base, so if they're both x's, if they're both a's, if they're both 7's, you can take the exponents and add them together. That's called the product rule. The exponent product rule. You add them together. So let's look at this example. So really, that would give me, I can look at the numbers and I can do 2 times 7, which is 14. And then I have x to the 5th plus 3. And then I have z, and this z has an implied 1, so go ahead and put it in n, 1 plus 4. Okay, show me that work. Giving me x to the 8th, z to the 5th. All right? So we're using our product rule there. Now, I've got ab to the 4th, a squared b to the 4th cubed. So that's like a squared b to the 4th times ab squared 4 times a squared b to the 4th. And as you can already hear, I'm kind of getting annoyed by that. But that would give me a to the 2 plus 2 plus 2, b to the 4 plus 4 plus 4, which gives me a to the 6, b to the 12. So here's another way to look at it. Because honestly, you're going to get big problems eventually, and you don't want to write that out however many times. I didn't even like writing it 3 times. You know, be thankful I did it. Okay, so what you could, how does 2 and 3 relate to get 6? How does 4 and 3 relate to get 12? Well, 2 times 3 is 6. So does that hold for the b? 4 times 3 is 12. So the power rule, so this is a power to a power, is you multiply. So you have n times n for your answer. So in this example, here's an example of using our power to the power rule. I'm going to write x to the 7 times 6 and y to the 3rd times 6. I guarantee you I'm not going to write that 6 times. That's just crazy. My hand would get tired. So 7 times 6 is 42. And 3 times 6 is 18. Okay, so you would have x to the 42nd, y to the 18th. Next example. What about this? Well, note that would be like x squared over y, x squared over y, and x squared over y 3 times. And if I sum those up, that would give me x plus 2 plus 2 plus 2 all over y 1 plus 1 plus 1, with a final answer of x to the 6th, y to the 3rd. Oops. Y to the 3rd. Okay. Well, here, just note that our power rule, it applies here, but the power rule applies to everything. So really, that's like x squared times 3 all over y, and the implied power is 1 times 3, giving you x to the 6th over y to the 3rd. Just because it's a fraction doesn't mean that the rules don't apply to everything. Let's look at this example. All right, we're going to work on the quotient rule. So this top one is x times x times x times x times x all over x times x times x. Those cancel, those cancel, those cancel, leaving me x squared. And once again, you're going to get big numbers. You don't want to do this. You don't want to be able to have to write out x, 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 x over x, 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 x for them to simplify. All right, so there's a different way to look at it. How does the 5 and the 3, how do I get to that 2? Well, I could have written this as x to the 5th minus 3, and that would give me my x squared. And this is what we call the quotient rule. So you can do x to the m minus n. So you can take the one on top and subtract the one on bottom. All right, let's look at this particular problem. All right, so that's the same. So the first thing I do is I'm going to look at those numbers. What do 2 and 6 have in common? Please tell me 2. So how many times does 2 go into 2? Once. How many times does 2 go into 6? 3 times. So I'm going to have 1 over 3. I have x squared over x squared. Ooh, those cancel. And then I have y to the 8th over y to the 4th. So I'm going to do 8 minus 4. So really, that's going to give me y to the 4th over 3. Now you can ask me what happened to the 1. I just didn't carry it over yet. But you can carry it over. It's not a big deal. You can do what you'd like. All right. Problem 10. And we will start this on the next video.